Hello everyone. In this video, we continue with the constant force of mortality fractional age assumption involving example with a life table. Recall these expressions under the constant force of mortality assumptions, and we are going to apply those in the example in this video. Let's take a look at the example. Given the following life table, calculate these 6 quantities, assuming a constant force of mortality over each year of age. The first quantity, we have L 68.25. That is at integral age 68, and the fractional part is 0.25. Applies the expression Lx times Px raised to the power s, and we get L68 times P68 raised to the power 0.25. To get P68, this is L69 over L68. And we already get L68 and L69 from the table. And then we can already get the quantities, or if you want to do a simplification, we get this. L68 raised to the power 0.75 times L69 raised to the power 0.25. So we are using this expression. And upon substitution, we get the answer. The next quantity, the force of mortality, mu 68.25. We have a nice formula, which is the negative of the lateral log of Px. The x is 68. Therefore, this is equal to the negative of the lateral of P68. Get P68, L69 over L68. Upon substitution, we get 0.008332. And this force of mortality is constant between ages 68 and 69. The next quantity is 0.45 Q63. X is 63, and then S is 0.45. The whole interval is between ages 63 and 64. We have 1 minus P63 raised to the power 0.45, and we get P63 from the life table. Upon substitution, we get 0.0021. The next one, 0.3 P65.2. The whole duration in concern, the whole interval is between age 65 to age 66. Start with 65.2 with a duration of 0.3 years up to age 65.5. The force of constant is the same, and this can be expressed as P65 and then raised to the power 0.3. Get P65 from L66 and L65. And we get a result. The next one, 6.8 P61. Factor into two P's. The first one, 6P61. Moving the individual to age 67, and then continue with the remaining duration 0.8. We have 6P61 times 0.8 P67. And 0.8 P67 is P67 raised to the power S. S is 0.8. To get 6p61, this equals L67 over L61. And then P67 is L68 over L67. Get these three quantities from the life table. And upon substitution, we get 0.9641. The last one, 2.1 bar 4.3 Q 61.6. Express this as 2.1 P 61.6 minus 6.4 P 61.6. And then the first term, the individual currently at age 61.6, and this is the probability that this individual will survive beyond age 63.7. This is the expression, and then similarly for the second term. For the non-integral expectation of life, the L's, we make use of this expression, Lx plus S equals Lx raised to the power minus S times Lx plus 1 raised to the power S. L63.7 is between the ages 63 and 64. We have X equals 63 and S is 0.7. We need L63 and L64 from the table. We get L63.7. And then L61.6 between the ages 61 and 62. Get this number. And we get L61.6. Together with L68, and we get the result, 0.0261. All right, that's it for today's video. In the next video, we will explore more examples related to fractional ages. Thank you and see you in the next video.